Hello, hello everyone. You are welcome to this clip 2 of part 8. This is the last part of our uh, modern wireless communications and applications course. In this clip 2, we are going to talk about some emerging technologies in wireless communication, and mainly in this clip, we will talk about CubeSat and also IoT, clouding, fog network, and so on. Let us start. So we start here with the CubeSat network. What is a CubeSat? A CubeSat is a small satellite device. It is usually determined as 10 centimeter by 10 centimeter by 10 centimeter. It is about 1 liter as size, and this 1 liter is, we call it as 1 unit U. CubeSat may consist of more than 1 unit. It can be like 2 unit or 3 unit and 6 units. The cost of deploying the CubeSat is very small compared with normal satellites, and also they have high flexibility. Many CubeSats have been launched by universities, and our University of Vaasa, we will have our CubeSat launching soon. You can see this is the website. Kvarken Sat is, we call it, or kvarkenspacecenter.org. So you can see the process and the development of this CubeSat process operation. Um, Okay, what is the difference between CubeSats and a LEO satellite? LEO satellite, or it is, we call it like a low orbit satellite, and those satellites are medium or large satellites. They can be on the altitudes of less than 2,000 kilometers. Actually, they are much more powerful than CubeSat because the small size of the CubeSat, we don't have that much operations or payload that we can put in the CubeSats. However, of course, for this medium or large satellites, they can be much more powerful. But the development, time and the efforts required to like send or launch one normal satellite, medium size or large size satellites, can be, the weight can be even like hundreds of kilograms. So it takes very long time. It can be up to 7 years of government programs, and also it can be very costly. So it can cost like $3 billion, like an Iridium next system. So it is very expensive. It takes a lot of efforts. It needs like governmental support. But for the CubeSat, it can be done like over like much less costs and also efforts. For example, we can use the what is known as commercial off the shelf component, and also we can use even like open source hardware. So if we know that there were some successful like hardware done in previous CubeSats, so many of them, they are open source hardware, so we can just use them. um, so it needs, as I said, that shorter development and deployment cycles, because we can launch many of them at a relatively much less cost. So we can have high reliability of them, and also for altitudes for 600 kilometers and above, they can actually, if it was well designed, it can like mandated 25 years or more time. So they can work for a very long time. Okay, so now the CubeSat, of course, they can have many different applications, but now for wireless communication, for what CubeSat can help. As we mentioned when we talk about the UAVs or drones, we talk about there are some areas on Earth that it is not covered well by different like conventional wireless communication like cellular networks, and still it is needed to be like track it, or we need to achieve communication in that remote areas. And also in case or in the time of like disasters, wars, earthquakes, when the conventional communication networks like collapse, we need some kind of alternatives that they can substitute the absence of communication network. So CubeSat here comes. So in such situation, we have the CubeSat that they can provide some activities here. And the idea, for example, we know or we mentioned before about drones or UAVs that they have limited power there. So and the power, the drone power, is used to flight the drone and also to provide communication, the power through communication system. And in some situations, we need drones with small like base station on the drone, and in that case, we know that the processing power of the baseband is very like considerable power. And in that sense, we can make some collaboration between drones and CubeSat to by providing or by sending the processing or the baseband signal to be processed in the CubeSat. CubeSat, they have solar cells and they are rotating without using any power on their orbit. The Even the distance can be large, like hundreds of kilometers, but because it is just free space, so the signal quality can be good. And in that sense, we can see our trade-off between the power processing required or the energy processing required on the drone, which can and what can be done on the on the CubeSat. And we have also observed it in the 5G that one of the major features of 5G, that part of the networking could be sliced or could be like virtualized and done over software. So even part of the network itself, part of the functions of the node B can be done on the cloud, as we will see actually, and we already discussed in the previous part. So in that sense, we can have some of this processing power to be done over the CubeSat, as we can see in this figure. So you can see that maybe the mobile phones in days of, like, if we have some situation that we have network absence, then it can be, the communication can be done between the mobile to the drones. But this is for the RF part in the physical layer, for the RF signal, like modulation, demodulation, those things. And but the baseband processing can be done over the CubeSat. And then we can have also routing on the CubeSat when we have like many of them on the space. Then it can be routed until it comes to it be sent to the to some network. So this is one option for the CubeSat they can do. And also CubeSat may provide space backhaul through the CubeSat large network, as you can see it here. And also communication and tracking in remote areas, so it can be connected to the remote areas like in oceans, sea, Sahara. So it can be connected there. They can have some like tracking for in some logistics applications and so on. And the good thing that, of course, maybe you ask, there are already satellites there, and this one can be like cheap option, and also it can be reliable when we have many of them. And also they can be deployed in lower like orbits, which means that the latency or the delay can be small. And when we have many of them, because the launching cost is very small. And also there's some important feature here, that it can be standalone, or it can be like non-third party solution. Because for the medium and large satellites, as we mentioned, they are very costly. It is very hard to be like launched by some medium or even large size companies. Actually, it can be very costly compared with the benefits that they can get. So pay like budget of 1 billion or several $billion is very large for the normal satellites. But here for the CubeSat, the cost is much less. It can be less than 1 per 10,000 for launching a normal satellite. And it means that it will be like very available option for in the future, for some companies, that they can launch their own small CubeSats on orbit, and then they can use them for their own application, not under third party companies or operators. Yes. Okay. Now we talk about Internet of Things, IoT. IoT is not very new. The term is around for about a decade, and they are already started in many applications. We have right now, currently, we have 25 billion internet connections worldwide. It is expected to be more and more, especially with these services and connected to the devices. The topic of IoT is very important in future, and the concept here that anything could be beneficial to be connected to the internet, it should be connected. Anything. So it can be, for example, home appliance, or devices, or machines, or it can serve in health system, in industry, in factories, in governmental applications, in security. They can provide services in many sectors. So, what is the concept of IoT, and what are the available technologies to be used, or because connectivity is the foundation for IoT. Without connectivity, we don't have IoT. So, what are the technologies available for this IoT? What are the requirements, and what will be the future? This is what we are going now to talk about. Okay, so in future, that or we define for the next generation, or after we like maintain the communication between people. So people are very well connected now, like physically or virtually, over the wireless networks, like voice communication, or over social networks, or over like Instagram, Facebook, chatting. Everything now is done very well. Um, the next step, on the next level, is communication between machines to each other. So, machine to machine communication, or machine type communication, is expected to be the core of the IoT applications. And for the future, we will need massive machine type communication, which means that the network should be able to connect like a very large number of devices in the same area. So one of the requirement that the network should, and this is actually one of the motivation for using for going to the 5G, because 4G was not able to achieve this requirement, where that we can connect 1 million device per kilometer square. So in small area, so it should be available that we can connect 1 million devices with like very high reliability and low latency. So because 4G was not able to do that, then this is one of the main or major motivations to go to the 5G, as we explained in the previous um, part. Um, so the communication requirement for most of the machine type communication, it costs, it include like low power consumption. It should be low power consumption at the device itself, not at the network, but at the device. So many of these IoT devices are not connected to the like main power utility, and some of them even in remote areas, which means that they are operated with a small battery, and it should like operate for years without changing the battery. Or actually many of them, they are disposal devices. It means that when the battery is finished or ended, then the device is dead. So in that sense, we need to keep it for as many years as possible. So it should be low power consumption. Many of the application are time critical. It means that the delay is very critical. So if the delay exceeded some limit, then it might have a like disaster, or the risk is very large. So it is called time critical missions or time critical applications. Um, Low data rate. Many of the machine type communication don't require very high data rate, not like 4G, like 4K streaming of video or something. So such kind of very high data rate is not needed in most of the machine type communication. There can be some. There can be some. For example, if we have a process depends on a high quality video, so in that case, it is exceptional case. But generally, most of the applications in IoT applications, they don't need very high data rate. Scalability and long range. So many of them, they should have the large elements in the same area, and it should cover over large distance or large range. Okay, so in the future, actually, we will have everything connected, people, body, machines, and then internet in the future. It will be like virtual and real world will be somehow integrated, and we will have what is known today as extended reality. What is the contents of IoT layers? So IoT consists of a perception layer. We could divide them into this number of layers. It can be more or less. You can find in different like resources or references, you can find different layers, but generally those are the general number of layers that we have. We have a perception layer. The perception layer is the sensor itself, the sensor which is like converting some physical value into electrical signal. For example, temperature sensor, or maybe a heart rate sensor, or pressure sensor, a fire sensor, a smoke sensor, whatever sensor that we use, that this sensing device that is connected, converted to the electrical signal, and then prepared for transmission. So we call it like this perception layer. This is the first layer that we have it here. Then we have the pre-processing layers. Some IoT devices, they are equipped with some symbol like microcontroller to make some basic operations for the signals before transmission. And this can be very beneficial to reduce the volume of the streaming of data, and this will reduce the requirement for the wireless networks. Let us give example. If we are monitoring certain place for example, the temperature in certain place, and no need, if we send, let's say, the temperature value every, let's say, 30 minutes. So we may change with using pre-processing layer, that if the temperature stay, for example, we send the temperature at the temperature was at certain time 20 degree. Okay, now we have in the pre-processing layer, if the temperature is within this 20 degree plus minus 1 degree, no need to send it again. So if the temperature is stay as it is, so no need to send. Then every 30 minutes, the receiver, if didn't receive anything, then they know that the temperature is within that range. And if the temperature goes beyond the period that it was given or specified, then they will send the new temperature. So the receiver will send just update for the temperature if it is outside that period. This will reduce a lot of power in the IoT device, so we don't need to transmit every time, and just we use this pre-processing layer to check the data. If the microcontroller is more powerful and we have more energy, we can make some compression for the data. We can make a lot of pre-processing operations, like maybe increasing the security, make some encryption, and so on. So this is called the pre-processing layer, which is augmented inside the IoT. Then we have the transport layer. The transport layer, this is number 3, this is number 2. The transport layer is used to transmit the signal. It can be, for example, IPTCP support, like based on that protocol, and also the communication type. It is over 5G, over GSM, the modem, and everything related to the communication layer. It is here in the transport layer. Then we have the processing layer. This processing layer, it can be in a cloud, for example. So the data can be transmitted over the cloud, and the cloud has some server, and in that server we have, let's say, a big like data storage, where we can store the data, we can process the data with much more like computational capabilities than the IoT itself. Above the processing layer, we have this is the fourth one. The fifth one is the application layer. In the application layer, we have that, for example, the application itself. For example, if the data was transmitted to the hospital, then the application layer, it can be like machine learning, which can detect the health situation of the patient, and if it is needed to take like fast response, or to call some human doctor, or and whatever was requirements here. So this is the application layer. And finally, we have the business layer, and in this business layer is taking care of the whole business model about the whole process. So this is simply the IoT concept and the layers of the IoT. This actually very nice presentation from Ericsson about massive and critical IoT. They devise or they divided the IoT applications into two categories. They call them the massive IoT and the critical IoT. In the massive IoT is the IoT applications where we need massive number of them. Like, for example, in smart building, you might have like hundreds of or thousands of sensors distributed in the building, maybe in the concrete itself, maybe to measure the humidity and so on, maybe in the windows everywhere inside the building, to measure the quality of the air quality, for example, and so on. So we might have hundreds, thousands of sensors in that smart buildings. We might have like mini sensors around, like logistics, tracking, and fleet management. We might have that in networking, in smart agriculture, for example. In some, like if we have hundreds of hectares, we can distribute thousands of sensors, disposal sensors there, to track the weather, to give some like information about the agriculture process, smart metering, and so on. Now, what is the common thing here in the massive IoT? It is massive in number, but it is not a critical application. I mean, the measurements or the data, if it was delayed, a few seconds, few minutes, sometimes in some applications even a few hours. It is not a big problem, it is not an issue. For the smart agriculture, for example, maybe they send once per day or once per week. The sensor itself, so it is not that critical. For smart metering, for example, if we have IoT device that they send the water consumption in certain building or the electrical consumption, it can be taken like per minute, per hour, per day, per week. It is not that critical in time. So those applications, they are not critical in time, and you can see that most of those applications, they are not for closed loop automation or fast control loop. They just monitoring. Of course, there can be actions taken as well, but it is not very critical in time. So those are called massive IoT. They should be also low energy consumption, because, for example, in this smart agriculture, or so it should be we cannot go in some like open field and change the batteries for every sensor there. It is not worthy to do that. So most of them, they are disposal devices, and they can be working for a couple of years. After that, we can just distribute new IoT devices there. Then we have the critical IoT application. In the critical IoT, that there is within a closed loop. There's a closed loop. Fast reaction must be taken. For example, for traffic safety and control, in such applications, of course, part of it can be done within the car itself. So we don't need to have data to be transmitted over the network, but sometimes in some applications we need to take information from the network, or to take the control over the network, or if the local control failed, then maybe we need to have external control. In that sense, the data is very critical, so we need to take action within few milliseconds. So now this is critical IoT. We have the remote healthcare. It is critical IoT application. Smart grid automation. For example, if we have failure happen, or fault happen in some of the network, then this fault, if the circuit breakers didn't or have not been disconnected for some areas, then the damage can be much more, and it can cost millions. So in that sense, we need to have very fast reaction. Sometimes we less than the time of one period of sinusoidal signal of the 50 hertz. It means that we need to have action less than 20 millisecond. If we have 50 hertz, then we should have action less than 20 millisecond to cut, for example, certain circuit breakers, to isolate the faulty region, and so on. So this automation should be done very fast. So now this is critical IoT applications. Industrial application and control, remote manufacturing, training, remote surgery, for example, or robot that they are doing some surgery remotely. So all these are critical IoT. Actually, most of the critical IoT, they need response time to be less than 5 milliseconds. In some applications, it can be even 1 millisecond. They are maybe less critical, but they need, or it is good to have this critical IoT, or critical time, like, for example, online gaming, virtual reality gaming, network over networks. So the sense will be very big difference between doing it over this critical time applications or normal networking. So here we have, this is for the critical IoT. They should be ultra reliable, very low latency, and very high availability. So it is not enough to be only low latency, but it should be also available. So maybe you have network that it can achieve 1 millisecond, but it has the problem that the probability to be unavailable can be like 10%. Of course, in that case, it is not good, because the communication can be absent within critical operations. So this should be taken. Those are the difference between massive and critical IoT. Okay, now I will give just a few IoT applications, and then we end this clip and we start another third clip to talk about more details about the clouding and how IoT is connected to the clouds. But here in the IoT applications, maybe we have them in a smart home, so where you can have like many devices inside the home connected to the by using IoT. The applications, for example, that we might have smart door or smart lock. When the owners in the home they go out like certain distance, then the smart lock they will lock the door for safety. And for example a smart washing machine, that it can select the proper time to be on to wash the clothes. For example, the owners are not at home, to minimize that the like disturbance, and also to select the proper time when the electrical tariff is small, the cost is small for using the machine. Maybe for the heaters, for example, the heaters they consume a lot of energy, or the air condition also. So the in the IoT, in the smart home, they are, for example, selected or selecting the proper time when they start heating the home, or making this air condition on to like make it colder for the hot areas. And in that sense they will reduce the energy consumption. So maybe in the smart home, they are just tracking the owner of the home. So when they are close to the home, like they know they will arrive within 15 minutes or 20 minutes, they start making these heaters or air conditions on. It can also watch when they switch between the using renewable energy or electrical like utility, if they want to sell energy or they buy energy, when they make on and off for the microwave oven. For example, if you before you left your home, you bought some food in the microwave oven, and the microwave oven they can check where are you now. So when you are like 5 minutes before you arrive home, then they make it on. So when you come, you can find your food ready. In the smart fridge, for example, they check what is missing in the fridge, and if there is no milk, for example, they can inform you that milk is missing, or they can itself order it from from market, so they will arrive to your door. So these applications actually they are already now in market, and but of course not used, or not like penetrated to every home. But things are going to change within a few years, where most likely that we will find them like very common. um, for health application, it is another application for IoT in health. So you can see that nowadays with our like smartwatch, like this one, for example, it can measure the heart rate. It can measure sometimes the skin temperature. For some people that they have some health issues or concerns, they can have more sensors connected to their body, and then his health or her health will be monitored all the time. And the communication can be done like over the mobile phone or over the Wi-Fi at home, or many times can be connected directly to the IoT, on the cloud. So we don't have the like over the mobile phone or the Wi-Fi, because sometimes the battery or the energy of the mobile phone is off. So in that case, this patient will be disconnected from the hospital, and we don't need that, or this can be dangerous in some cases. So now as we will see in the next clip, when we talk about new communication technologies designed for the IoT application, where we can actually like just skip this mobile phone or Wi-Fi and can be connected directly, because Wi-Fi, it has limited like coverage maybe inside your home, but when you are walking around, then you are not connected through the Wi-Fi. If your mobile is not with you, then this person will be disconnected, and this will can be, as I said, a problem, or it can be dangerous in some situations. Because of that, we will see this new like IoT applications, and many things can be, as you can see them here, many things can be measured in the health concerns, and can be connected directly to the hospital, to the emergency unit, and so on. In smart factory, actually, is one of the very important applications for this IoT. Sometimes they call them industrial IoT. It is II or double IoT. And the idea here is mainly how to connect everything in the industry, machine to machine, machine to people, machines to sensors, and to business, to retail business, to the manufacturing. What is the demand? What is the provided material? What is the raw material from where they come? This chains of process that it can be all the time under monitoring with this IoT application, or it is known as smart factory. So they are actually, as I said, very important applications also in these smart factories, where we can see that in the smart factory, with the assist of wireless networking and IIoT, data should be delivered to the right place in the production chain, and at the right time. So this is very important. And of course, it is not just data, it is not just streaming of data, but we need to have also algorithms for data analysis, data fusion, data mining, machine learning. A lot of processing and operations must be done here, and this will be major feature for the industry era 4, that where we have like this high competition environment and high dynamic business environment. As you can see here, that wireless connection should be available in every items, in factory, in logistics, in manufacturing, in energy, and in tracking, in demands, marketing, everywhere that data is connected. And now maybe this was it was like scientific fiction before, like 20 or 30 years ago, but now it becomes a fact, and now we have, it becomes a real thing, and now we have, this is doable, this can be done with very low cost IoT devices. The issue now, what we can do, with this huge streaming of data, this big data now available everywhere, and what kind of clever algorithms or smart algorithms that they can extract much much information, or more information to be utilized in the right way. We can have many other like IoT applications, like autonomous farming equipment, shipping containers and logistics tracking, biometric cybersecurity, military applications, safety and security tracking, predictive maintenance, smart grids, energy conservation, supply chain and logistics, smart environment, social life and entertainment, smart transport, smart traffic, just name it, just name it. So IoT becomes it actually becomes, and it will become more in the near future, almost in every branch of life. Okay, so let us stop here. It is already enough time for this clip too. So next clip will be more about communication core of IoT, clouding, fog architecture, and what is the future. Thank you very much, and see you in the next clip. Thanks.